Hello friends, I am Dr. Lokesh Jasrai. In the previous video, we have discussed how to execute the inner model multicollinearity statistics based on VIF, and now we are going to discuss the path coefficient and p-values in the process of hypothesis testing. So let us understand what does it mean by the path coefficient. The path coefficient measures strength and direction of relationship between the constructs in a structural equation model, and based on p-values at a specific level of significance, we support or not support the hypothesis, or we accept or reject the null hypothesis. So to execute this one, open the smart PLS. Now this is our model, and we already executed the bootstrapping with the 5,000 subsamples, and then you can find out the path coefficient. So once you click on this left hand side, you can find the path coefficient table, in which you can find the mean, standard deviation, t statistics, and the p-values. Let us go to the PPTs. Now in this way you can find the path coefficients in a tabular form, and in the diagram also you can find these values. So on the smart PLS, you can find, once you click on the graphical output, you can find these values. So these are the path coefficients along with the t statistics. And if you click on this, so that will be, if you want only the p values, click on this, only p values will be appeared. If you click path coefficient and p values, both values will be appeared on the model. If you click path coefficient and t statistics, then these values you can find on the model, and if you want only the t values, that will be appeared on the model. So in this way you can illustrate specific statistics as per your discretion. And now, so this is, in this particular table, the original sample that indicates your path coefficient beta. Now let us understand. Now we have to observe the path coefficient beta along with the p-value with each pair of the constructs. Like for SSHP, we have to consider these values. Similarly for FW and HP, and for WLB and HP, and for HP and LS. So how you can interpret this one? Let us say, for example, SS and HP, the beta is 0.053 and the p-value is 0.23. 2. Now, this beta value indicates the strength and direction of this relationship. If it is closer to 1, then it is a strong relationship. If it is closer to 0, it is a weak relationship. If it is positive, then the both constructs are positively associated. If it is negative, then the constructs are negatively associated to each other. Now, in this case, SS and HP, the relationship is positive, but not statistically significant, as the p-value is greater than 0.05. Hence, we can conclude that the social support does not have a significant effect on the happiness in this model. It means our hypothesis is not supported. But in the case of FW and HP, the beta is strong 0.6 and the p-value is also significant. So we can find out that financial well-being has a strong positive effect on the happiness, and it is the strongest predictors of the happiness in this model, and our hypothesis is supported. Similarly, if we examine the relation between WLP and HP, then again it is significant, but it is weak because the beta value is 0.2, and the model is, and this relationship is also supported in this model. And the between the HP and LS, the relationship is positive and statistically significant. This indicates that happiness has a strong positive effect on life satisfaction because beta is 0.5. As happiness increases, the life satisfaction also increases significantly. So in this way, you are required to examine the beta values along with the p values for each pair of the constructs and interpret accordingly. Now, how we can make the overall interpretation for this model? Financial well-being is the most influential factors in predicting happiness because it is highest beta, followed by work-life balance also significantly improves the happiness, but the social support does not significantly predict happiness because the p-value is greater than 0.05 or the p-value is non-significant. Okay, now one more important concept related to the beta is what is the difference between the beta and R. So R is a correlation coefficient and beta is a path coefficient. Now what is the difference? The path coefficient is standardized regression weight showing the direct effect of one variable on other in a context of SEM model. Whereas correlation coefficient R is the linear association between two variables without considering the other variables. This is the main difference. So say for example, the correlation coefficient measures association only, whereas the beta measures direct effect in the model by controlling the other variables. So say for example, if the R is 0.75 means X and Y move together strongly, but no direction or control for the other variables. But in case if beta is 0.5 means 1 unit change in X increases by 1 unit change in the x increases y by 0.5 units after controlling for the other variables. So this is the important difference between the beta and R. So correlation indicates the role relationship strength, no control for the other variables, whereas the path coefficient indicates strength plus direction of effect within the SEM model controlling for other path. So this is all about in this video in which you learned about the application of beta, application of p-value for your rejecting or accepting the hypothesis between the constructs. So thank you for watching this video and kindly subscribe the channel for more videos in this series. Thank you so much.